Okay, welcome back. So before you watch this video, you should have done the practice problems on solving by factoring. You should have checked your answers against the solutions that I would have posted on Google Classroom. We're going to launch right into today's lesson, and we're going to start just by solving some more of these equations. And again, we're going to follow that pattern that we started yesterday. I'm going to rearrange into standard form. Okay, this one's already rearranged. ax squared plus bx plus c equals 0. Next, I'm going to factor two numbers that multiply to 15 and add to 8. What are those? No one's putting their hand up? Oh, because none of you are in class. You're all at home. Okay, so the two numbers are positive 5 and positive 3. Those multiply to 15 and add to 8. And then I've got to think what makes this first bracket equal to 0, what makes the second bracket equal to 0. So x could be negative 5 or negative 3. And again, the convention is to lift those from smallest to largest. No problem. So that's what we were doing in your earlier lesson. Okay, let's just do one more example. We'll keep going. X squared plus 6x plus 6 equals 0. Again, already in standard form. I've got to think of two numbers that multiply to 6. So they've got to multiply to 6, and they've got to add to 6. And they both have to be positive, right? Because I've got positive and positive. Okay, two numbers that multiply to 6 can either be 1 and 6 or 2 and 3. 1 and 6 adds to 7. 2 and 3 adds to 5. So I can't factor this. So remember that when I'm solving an equation, what I'm really doing is I'm finding the zeros of this parabola. But I can't seem to factor this, so I've kind of run into a roadblock here. Okay, why don't we look at this parabola on Desmos and see what's going on. Does this parabola even exist? Does it have zeros? Why don't we take a look? So I'm going to move over to desmos.com. And the parabola that we were thinking about here was x squared plus 6x plus 6. Okay, well, I should have found an answer. I do have two zeros. But if we take a look, my zeros are now decimals, right? I would have never factored and found those two numbers. These two numbers actually do multiply to positive 6 and add to 6, but wow, that's pretty strange numbers. Decimals, irrational. So it turned out that factoring doesn't work. It only works for whole numbers and fractions. It's not going to work for what we call irrational numbers. These numbers actually go on forever. Desmos is just rounding them for us. So I should be able to solve this quadratic equation, but I can't do it with factoring. In fact, it's impossible to factor. So maybe we should add that to our note. This is impossible to factor. Well, luckily, there is a formula that we're going to use that will solve. I'll find my two answers for x just the same way, even when I can't factor. So we call that the quadratic formula. And what it does is it solves any quadratic equation, even when I can't factor. So I'm going to write out the formula here. It's actually already on the front of your booklet as well in that cartoon, but I'll write it out again. So the formula is nice and short. It's negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So maybe not so short. I've taken a lot of math courses in my life, in high school and in university, and this was always the longest formula that I ever had to memorize. So we'll practice it a bunch today. You might see some strange things that you're not used to. What does this plus minus mean? And what does it mean when I have everything under the square root? But that's called our quadratic formula, and it's going to give me answers for x. And the quadratic formula only works when I have my equation set up in standard form. So we're going to now solve example 2. You might have thought that was a typo. It's not. I'm going to solve example 2, which I couldn't solve by factoring. I'm going to try to solve it with the quadratic formula. So the first thing I want to check is this in standard form? Do I have ax squared plus bx plus c equals 0? I do. So what I'm going to do first is I'm going to write out my a value, my b value, and my c value. So it's good to stay organized. In this case, a is just 1. There's nothing in front of the x squared. My b value is positive 6. And my c value is also positive 6, as it turns out. Okay. The next thing I'm going to do is I'm going to rewrite my formula. So the more we write something, the quicker it becomes kind of solidified in our brain. Sometimes this is called the midnight formula. I think it's because if someone like shakes you awake at midnight, you should just wake up yelling negative b plus minus square root of b squared minus 4ac all over 2a. So it kind of becomes ingrained in your brain as we do a lot of these problems. A lot of students ask me, do I need to memorize this? I guarantee it that if you do all your homework questions, this will be memorized and kind of stuck in your brain. So you definitely don't need to memorize for any quizzes, and we'll talk about it whether you want to memorize it for a test. What I'm going to do next is I'm going to now plug in my values a, b, and c for wherever I see a, b, and c in this long formula. I'm going to make sure, as always, whenever I sub in, it's now going to be crucial that I substitute in with brackets. So I've got negative b plus or minus square root of b squared minus 4, whoops, I have the same color for a, that's okay, times a times c. Let me make sure that's all under my square root sign. And I'm going to divide everything by 2 multiplied by a, which is 1. So now I just have a formula that I'm going to evaluate my right-hand side. It's only got numbers, so I'm just plugging in values and evaluating. So I have negative 6 plus minus, well, 6 squared is 36, minus 4 times 1 times 6 is 24, all over 2. Okay, so I'm just simplifying this. I'll do one more step. Negative 6 plus or minus square root 36 minus 24 is positive 12, all over 2. Okay. Now here's where it gets a little bit interesting. What does this plus or minus mean? And the rationale here, the thinking here, is just like when I factored, I could find 2 possible values for x. The plus or minus are what's going to give me 2 possible values for x. So I'm going to keep going. So I'm going to split this into 2 equations. To find the first x, I'll call that x1. When I write a number down to the right, or a subscript, and that's just a label, so I'm calling that my first x, or x1, and we're going to use the plus, so negative 6 plus root 12 over 2, and I can have an x2, which is negative 6 subtract root 12 over 2. And if you want more space, you could do this on the right-hand side of the page. So I've got 2 equations which are going to give me different values for x. So let's take a look. So I've got negative 6 plus the square root of 12. And the square root of 12 is not a rational number. That's why we couldn't factor. The square root of 12 actually goes on forever if you want to try that in your calculator. Sorry about the glare. So I'm going to add those. Be careful of your bed mass. So I'm going to do the top of my fraction first, and then I'm going to divide by 2. I'm just going to round to a couple decimal places. So x1 equals negative 1.27. And x2, this time I'm going to use the subtraction. So negative 6 take away the square root of 12. And you will need a calculator for this, because again, the square root of 12 is not a simple number, a rational number. I'm going to divide again by 2. And I have negative 4.73. So just like when I factored, I have 2 possible answers. So when factor is impossible, we can use the quadratic formula. And again, if I go back to where I was on Desmos, this is exactly the 2 zeros that we expected to see. So when I solve a quadratic equation, I'm finding the 2 zeros of the parabola, even when I couldn't factor it. So this is something new, that when I couldn't factor a parabola, it might still have zeros, and I can find them using the quadratic formula. So the quadratic formula always works. It's very reliable. There's not a lot of thinking or creativity like there might be with factoring. The problem is it's quite a lot of steps of algebra. We've got to be really careful that we don't place a number wrong or change a sign. It's harder to check the answers in our head. Unlike factoring, where once we have the 2 numbers, we're pretty confident that we're right. So quadratic formula, I really encourage you to double check your work, make sure you have organized, kind of clear writing, to make sure that we're getting to the same two answers at the end of these steps. So we're just going to do one more example in our video lesson. Again, we're in standard form. I don't need to rearrange. I'm not going to use colors this time, but I'm going to say my A value is 2, my B value is -5, and my C value is -7. Again, my quadratic formula, -b plus or minus square root of b squared minus 4ac, all over 2. And I say all over because probably the most common error is people don't extend that fraction far enough, which would change your answer. Now I'm going to start plugging in. Again, the parentheses are crucial. So -5 plus or minus -5 squared minus 4 times a times c all over 2 times a, which was 2. So my first step is just to plug in a, b, and c everywhere it goes into the quadratic formula, and then I'm going to simplify. Especially I want to be careful when I simplify these signs. So -5 is +5. I want to keep my plus minus. If I split into two equations too early, I'm going to have to do a lot of the same work twice. So I'm only going to do that once I've kind of simplified everything else as much as I can. -5 squared, -5 times -5 is 25. So b squared will always be positive. Here, notice I've got two negatives. So I'm going to have a positive. 4 times 2 times 7 is 8 times 7, which is 56. And again, you're welcome to kind of put this all into your calculator in one step. And 2 times 2 is 4. Okay. Don't let that denominator escape, or don't forget to always include that in each step. I'm going to keep simplifying, so I have 5 plus or minus the square root of 81 divided by 4. Okay. Now I can actually do one more step, because in this case, root 81, well, the square root of 81 is just 9, because 9 times 9 is 81. Uh-oh, I shouldn't have a square root sign anymore. It'll be 5 plus or minus 9 divided by 4. And now I've simplified as much as I can, so I can split into x1 is going to be 5 plus 9 divided by 4. And my second x value, the second zero of this parabola, 2x squared minus 5x minus 7, is going to be 5 subtract 9 over 4. And then I can just solve these two equations. So x1 equals 14 over 4. And if I reduce it, that's 7 over 2. And x2 equals -4 over 4. So x2 equals -1. Okay, so it's just another example of the quadratic formula. So again, this one I think I could have factored, but the quadratic formula will still work. And we'll kind of talk about, I think in tomorrow's video lesson, about when should I solve by factoring, when should I solve with the quadratic formula. I just want to talk about one last thing today. We've been talking about when I find these solutions, these are really the zeros or the x-intercepts of that parabola on the left side. Right? That's a parabola in standard form. Now, if you remember, sometimes our parabolas have two zeros. So my quadratic equation could have two solutions. And all the examples we did today so far have had two solutions. I've had an x1 and an x2, and they've been different. There are some cases where a parabola only has one x-intercept. And so I'm only going to get one solution to my quadratic equation. We'll talk about when that happens. And lastly, as we talked about in a previous unit, my parabola might have no zeros, no x-intercepts. So I'm actually never going to find x1 or x2, because my quadratic equation is going to have no solutions. It's going to be impossible to find solutions. We have a special name for the part of the quadratic formula under the square root sign. And we call that the discriminant. So this should be a new word, I think, for all of us. The discriminant is the part of the quadratic formula under the square root sign. So it's that b squared minus 4ac part. So that's called the discriminant. And the discriminant is actually going to tell us how many solutions there are. So all the examples we've done, you're going to go back and flip through. B squared minus 4ac has always been positive. And that gives us two solutions because I'm adding or taking away a different positive number. So 5 plus 9 is different than 5 minus 9. So I have two possible answers. It is possible sometimes that my discriminant, b squared minus 4ac, is equal to 0. So if I had a 0 under the square root, I would just be adding 0 or taking away 0. So my x1 and my x2 are just going to be the same. So if the discriminant equals 0, there's only one solution. I guess I should fix that to there is one solution. I want to make sure my grammar is correct. So if there's nothing under the square root sign, it's just plus 0 or minus 0, won't change my answer. That's when I have one solution. Now it's also possible that I get a negative under the square root sign. What happens when I try to take the square root of a negative? So you can try on your calculator now. Maybe pause the video and give that a shot. If I take the square root of a negative number, my calculator can't do it. So negative numbers don't actually have real square roots. Because if you think about what a square root means, it means two numbers times each other that equal the number under the square root. But the problem is, I can't multiply 2 times the same number to equal a negative. So for example, I'm trying to find the square root of negative 4. Well, the answer is not going to be 2, because 2 times 2 is positive 4. But the answer also isn't going to be negative 2, because negative 2 times negative 2, my answer is still positive 4. So there's no number that I can times it by itself and get a negative. So if you ever get a negative under the square root sign, which means a negative discriminant, your calculator is going to give you an error because there are no solutions. There are 0 solutions, which is this third case of parabola with no zeros. So on some of the questions I'm going to make you do today, I won't make you solve the whole quadratic formula. I'm just going to have you check the discriminant, and then you can tell me, are there 2 solutions, 1 solution, or 0 solutions? So that's the quadratic formula. The best way to get used to it is to practice. The answers can be very difficult to check on your own, so please make sure you check against the bottom of the page or look through my solution in the classroom. Please send me an email if you don't understand. We're going to solve all of A through F using the quadratic formula. Here you're just going to tell me how many solutions. Are there 0, 1, or 2? Then again, we're going to put these into standard form and then use the quadratic formula to solve. So you've got 15 more practice problems, and that's going to be it for what I expect you to do in math today. I'm going to come back with one last lesson and an assignment tomorrow as well. And again, feel free to join me at study hall or send me an email if you have any questions. Okay, bye for now.